Good morning, 7th grader. Our lesson is Signs of Chemical Reactions. The objectives that we learn at the end of this video are: list the 4 pieces of evidences for the occurrence of chemical reactions, and write the word equation of a chemical reaction. First, let's recall back. Identify, don't forget it's indicate plus justify, the picture that shows a chemical transformation and the one that shows a physical transformation. Observe, here we have a tree. From the tree we can cut some wood. Okay, from this tree, these are the woods. Also, these woods could be burned. As you see, do we obtain new substances when we cut the tree into woods? Think. Then, good, it's a physical transformation, since the tree, big piece, is cut into smaller pieces without changing the identity of the wood. While, let's talk about burning some woods. Do we obtain new substances? Good. Wood on fire will change into ash and carbon dioxide gas. That's good. Then, what do we call it? Good. It's chemical transformation, since new substances with new identities are obtained. Ash, carbon dioxide, etc. Observe the following figure, then answer the questions that follow. Observe it, we have photosynthesis process. Indicate the type of the adjacent transformation. Yes, we started from these substances to obtain these substances. Then, do we obtain new substances or no? What do we call it? Good! It's chemical transformation. Wonderful! Now, mention the reactants used in the adjacent transformation. Knowing that reactants are the used substances. Yes, what do we use at the beginning? Good, it's carbon dioxide and water. Nice. Why we didn't mention the sunlight? Can we consider sunlight as a reactant? Think about it. Yes, we used the sunlight at the beginning. Why we didn't mention it as a reactant? Think. Good. No, since it's an energy, not a substance. Wonderful. Name the obtained products. Products are the obtained new substances. What are the obtained new substances? Nice. Oxygen and sugar. Good. Now, let's recall back. The nail will get rusted. The reactants to give these products. Burning a magnesium ribbon, as you see here. And adding some sulfuric acid to the sugar. All these are considered as chemical reactions where we start from reactants to obtain a new substances known as a product. These are chemical reactions, or we could say chemical transformations. But the question is, how could the occurrence of chemical reactions be proved? How could I prove that there is nice signs of chemical reactions? Good. Let's observe the first experiment to show the sign of the chemical reaction. For today, we're going to list the signs for the occurrence of a chemical reaction. And how could we infer that a chemical reaction is taking place depending on some signs that we observe? For the first experiment, we'll use potassium permanganate. Observe its color carefully. Do you see it? And oxygenated water. Look at its color also. And a few drops of sulfuric acid. I'll open the sulfuric acid. Take a few drops from it using a dropper. Add approximately 5 drops of the sulfuric acid into the oxygenated water, and after that I'll add them together. Observe what would happen. Okay? Look, it's wonderful. Look at the bubbles and look at the changing in the colors. I place it aside till the color change into colorless, since it must show a colorless reaction. I place it aside, leaving it for a certain minute. You see, this is the result after a few minutes. It turns colorless. Now, name the used substances. Yes, what do we use in the experiment? Good. Potassium permanganate, oxygenated water or hydrogen peroxide, and sulfuric acid, few drops of sulfuric acid. Now, give one word, only one word, to describe the used substances. Yes. What do we call them? Nice. They are known as reactants. Indicate the color of the potassium permanganate solution in the beaker. Look at the beaker. What is the color of potassium? Nice. It's purple. Indicate the color of the oxygenated water solution in the beaker. Yes, it's colorless. Nice. We start from colorless solution. Now, what do you observe after mixing them together? Look here at this picture. Good. We have effervescence or gas bubbles. As you see, do you observe the gas bubbles? Now, what is the sign for the occurrence of this chemical reaction? How could I prove that there's the chemical reaction taking place? Look, how could I prove it? Good! Release of a gas in the form of bubbles. Concerning the first sign of a chemical reaction, which is production of a gas, let's observe this reaction to know how could we infer that a gas is produced. What we have here, some vinegar and baking soda. Do you see what happens? Good. Bubbles are appeared, as you see here. Fizzes. Fizzes where some drops of the liquids are going out from the beaker. And sometimes I can observe the released gas. To know the second sign for the occurrence of this chemical reaction, observe experiment 2. Concerning the second experiment and the second sign for this chemical reaction, I'm going to use lead nitrate and potassium iodide. The potassium iodide is a powdered solid. For that, I'm going to place few grams of potassium iodide in a test tube and dissolve them in water to obtain an aqueous potassium iodide solution. As you see, they melt. You see? I plate them aside. This is potassium iodide solution. And I put in another test tube few milliliters of lead nitrate. I'm adding few milliliters of lead nitrate into another test tube. Observe their colors. What do you see? What are the colors of these two solutions? I pour potassium iodide over the lead nitrate and observe the change. Wonderful color. Look at the obtained color. Do you see? Nice color. This yellow color indicates the occurrence of a chemical reaction, since we start from two colorless solution to obtain yellow one. Name the used reactants. Good. They are lead nitrate and potassium iodide solution. Indicate the state of the used reactants. Yes, look at them. What are the states of them? Good. Both are liquid solutions. Wonderful. indicate the initial color of the lead nitrate solution and that of the potassium iodide solution. Look at it. Look at both of them. Yes, the starting materials. Nice, both are colorless. Now, after mixing them together, as you see, I performed the experiment mixing the colorless lead nitrate and colorless potassium iodide. What happens after mixing them? Look at the figure. Try to know. Good. It's a yellow substance is formed. As you see, indicate the sign of this chemical reaction. In your opinion, what is the sign? How could I infer that there's a chemical reaction? Nice, with changing color. Here from colorless into yellow, but I may have some other colors. Indicate the state of the yellow substance. Look here. Do you observe it in the figure? Yes, it's precipitate at the bottom. It's a solid. Mention another sign of this chemical reaction. Now, in your opinion, what is the other sign? We obtain a solid. Formation of a precipitation, where I started from two liquids to form a precipitated substance. In a solid state, the formation of a precipitate and the change of the color here are visible signs that we can observe that indicate a chemical reaction is taking place. Then, the second sign is formation of a precipitate. How could I infer that precipitation is obtained? A precipitate is a solid substance. As you see here, do you observe the solid substance at the bottom? That forms during a chemical reaction between two liquids, then starting from liquids to obtain unexpected solid substance. The other one is changing color. Yes, but when does the color change indicate that a chemical reaction has occurred? How could I infer that? Changing a color here, when changing color is unexpected. Look here, I have blue mixture and a yellow one. Upon mixing them together, the expected color is a green one. Good, we'll expect green one upon mixing blue and yellow liquids. But getting a green liquid from mixing these two colorless liquids, it's unexpected. Now, this changing in color indicates the occurrence of a chemical reaction. Do you see? Unexpected green color from two colorless liquid. How to represent a chemical reaction? Let's observe this figure here. I have egg, sugar, salt, vanilla, butter, flour. Upon mixing together, what do we get? Yes, when we mix these substances, yes, cake. Nice. We'll obtain some cake. Then flour plus butter plus sugar plus vanilla plus salt plus egg to give cake at the end. These are known as, what do we call them? Reactants. Where here I have 6 reactants, 6 starting substances to obtain the cake, which is the product that I'll obtain. The cake is a product. I have only one product. Yes, I could, starting from 6 reactants to obtain one product. This is known as chemical equation. A chemical reaction can be represented by a chemical equation as follows. I write the name of the reactants first, placing between them plus as you see, then draw an arrow. After that, I write the names of the products and also drawing a plus between them. The first plus between the reactants means reacts, while the arrow means give. Here, observe this chemical reaction. Baking soda and vinegar. At the end, we'll obtain gas plus dissolved salt. Let's place plus by react and the arrow by give to give this statement. The statement that we'll obtain is Yes, by placing these symbols, the reactant 1, which is baking soda, reacts with reactant 2, which is vinegar, to give product 1, which is a gas, and a product 2, which is a salt. Now, this is a chemical reaction, baking soda plus vinegar, arrow gas plus dissolved salt. How could I represent it in your opinion? How could I write the equation? Nice, baking soda plus, that stands for react with, vinegar to give gas plus salt. The application, pause the video each time, okay? Observe here we have lead nitrate and colorless potassium iodide. What do we call these substances? These are the starting substances. Pour lead nitrate over potassium iodide to obtain lead iodide, as you see precipitated as a yellow, and potassium nitrate. Give one word to describe these substances. How could I infer that a chemical reaction is taking place? Give me a sign, one sign. Could you give two? Think about two signs. Yes, starting from colorless to obtain yellow substance. Give me two signs. Wonderful. You are wonderful students. Good. Yellow precipitation. Now, lead nitrate reacts with potassium iodide. Where reacts with, do you see? Lead nitrate reacts with potassium iodide to give. This arrow indicates to give, to produce lead iodide and potassium nitrate. How could I change it into a chemical reaction? By placing the name of reactants and the products. Think. Yes, pause the video and try to solve it by yourself, okay? Placing reacts with the plus to give by an arrow and by plus also. Good, it's lead nitrate plus, which is react with potassium iodide, arrow that stands for to give, lead iodide plus stands for and, potassium nitrate. Observe the third experiment to indicate the last signs of a chemical reaction. Observe here, we have some hydrochloric acid. We add them into an Erlenmeyer, as you see. Add over the hydrochloric acid a few grams of powdered zinc. Do you observe the bubbles here? Do you see the bubbles and releasing of a gas? Observe the temperature. This is the initial temperature, which is 21 degrees Celsius. Do you see the gas that's obtained here? What happens for the temperature? Let's check the temperature again. What's happened? It's turned 32, 33, 34, 35, and it's increasing. It's still increasing. But I didn't place it on a fire. This reaction and this reaction, there's no fire. Why does the temperature increases by itself? Think. Look, it's still increasing. It reaches 49. Let's answer some questions. Name the used reactants. Hydrochloric acid and zinc powder. Indicate the state of the used reactants. Yes, they are. What about hydrochloric acid? Look at it. Look at this zinc. Good. Zinc is a powdered solid and hydrochloric acid is a liquid one. Observe the reaction again. Observe it carefully. Do you see? Do you see the bubbles? Do you observe the bubbles here? Look carefully. Then record the observation that you have. What do you observe? Nice, bubbles are observed here. Indicate the sign of this chemical reaction. In your opinion, what is the sign here? When you have bubbles, nice, release of a gas in the form of bubbles. Now, let's check the temperature. Use the thermometer. Look at, this is the initial temperature, this is the final temperature, where the initial temperature indicates 21 degrees Celsius. And at the end, the final temperature gets 50 degrees Celsius. As you see here, what happens for the temperature? How does the temperature vary during this reaction? It starts from 21 degrees Celsius to reach 50 degrees Celsius. Good! The temperature increases from 21 to 50 degrees Celsius. But what does increasing in temperature indicate? What does it indicate? Guess? Release of energy in the form of heat without being interfered. We didn't place them on a fire. It increases by itself. Then, what does the release of energy indicate? The release of energy here indicates the occurrence of a chemical reaction. It's an evidence. Indicate another sign of this chemical reaction. Yes, what is the other sign now? Production of energy. It's not only increasing in energy. This energy could be increases or decreases. Then as a summary, a chemical reaction can be detected by one of the following signs or evidences. The color changes, as you see here, starting from colorless and copper stream to obtain blue color solution. A precipitate is formed when we add lead nitrate over potassium iodide to obtain a yellow colored solution. A gas is released in the form of bubbles when we add vinegar over chalk. We can observe the bubbles here, as you see. And the last one, the energy is exchanged. Here we have the explosion. When we have explosions, a lot of heat is produced. And also, a chemical reaction can be represented by a chemical equation as follows, where I write the names of the reactant 1 and reactant 2, placing a plus between them that indicates reacts with, then draw an arrow that stands for to give or to produce. At the end, we write the name of the products and also drawing a plus between the name of the products. It's evaluation time. Observe the following experiment, then answer the question that follow. Don't forget to pause the video. Sodium hydrogenocarbonated. In the beaker we have sulfuric acid at temperature 25 degrees Celsius to give bubbles of carbon dioxide gas, and sodium sulfate here at temperature 2 degrees Celsius. Mention two signs for the occurrence of the above chemical reaction. Pause the video. Good. Changing in temperature and releasing gas. This is also the experiment. In this reaction, indicate the reactants, where are the used substances at the beginning. What do we have? Starting from sodium hydrogenocarbonate and sulfuric acid. Good. And what about the products, which are the obtained substances here? What are the products? Name them. No, they are sodium sulfate and carbon dioxide. Now, write the word equation of the reaction taking place. Word equation. Pause the video now. They are the starting substances. We write plus between them, arrow, write the products, and also place a plus between them. That's how I write the word equation. Good. Sulfuric acid plus sodium hydrogen carbonate, arrow, sodium sulfate plus carbon dioxide.